Hello, and welcome to a series that is going to focus on getting a UAV simulation working in your Linux environment. Specifically, we'll be using a software in the loop, either Pixhawk or Autopilot, and use that in conjunction with MAVROS to provide an easy and simple way to simulate your own code and control your drones. Both of these systems have existed for a few years now, but the installation instructions are quite spread out all over the place from different websites. As a result, the entire installation process for the full stack can have many different errors, and I want to create a series here that would demonstrate exactly how to do this installation process step by step so that you can get running and not have to focus on trivial errors and waste time that way. One thing that other resources do not provide is a general high-level overview of how all of this stuff comes together. I'll be providing that in this video. The next videos will then start to actually install these components. Let's get started here. There are three major components effectively in this simulation pipeline. On the left, and at the lowest level, we have the firmware software in the loop, either the very popular Autopilot or PX4 firmwares. This, in effect, simulates the actual flight controller. This has the same safety checks. It also has the same response to various types of queries, like changing the mode of flight a drone may take. Then, in the middle, there's the Gazebo simulator. The Gazebo simulator provides the physical model for the drone that the firmware on the left sees. In effect, the Gazebo simulator can have valuable sensor data. As such, you can also add depth cameras and LiDARs onto your drones and simulate that as well, in addition to basic controls by using Gazebo. On the left, the Autopilot firmware commands the motors in the Gazebo simulation to move. And in turn, the Gazebo simulation provides an estimate when there are collisions or there are changes in angular position, such as using an IMU plugin. On the right, there's the ROS and MAVROS process. This is where people will write their code, and they'll integrate with the rest of the system. ROS and MAVROS are able to communicate with the firmware and the flight controller through a protocol called MAVLink. MAVLink is a fairly standard protocol, and it's easy to use, but MAVROS abstracts away this protocol layer and allows people to use ROS topics and services over just a protocol. Moving on, this is how the system would work in a production configuration without the Gazebo simulation. There is a physical flight controller on the drone that is responsible solely for the control of the drone and the inputs of certain sensors that may be important, like depth sensors for landing configurations, for example. The flight controller can then pass on sensor information from GPS, depth sensors, and so on to the ROS and MAVROS process. And this ROS and MAVROS process should run on a companion computer. Examples of these could include a Jetson Nano, Jetson NX, any real Linux Ubuntu-based computer can do it. Specifically, these computers need to have serial ports or UART in order for it to connect to some of the popular flight controllers that are out in the market today. And so in order to actually control the drone, the ROS and MAVROS code ends up sending MAVLink commands over to the flight controller, and the flight controller responds and then possibly sends back more information. And that is how this whole process will work on the real drone. This is a picture of the firmware software in the loop for Autopilot. As you can see, there is a main terminal in the top left. There's also, on the bottom left, a waypoint mission list. Here, you can see that there are nav waypoints, meaning that these are waypoints that the simulated drone should go through. On the bottom right is a console of the firmware. And furthermore, this can be very helpful in debugging because you may not have access to the console in real time when you're trying to do this integration process on the drone. And up on the top right, you once again have a map of where the drone is and also where the waypoints are. And you can see that the drone is in between points 1 and 2 on its way to waypoint 2. This is an example of an image from the Gazebo simulator. Here's a hexacopter called Typhoon. And also on the bottom, as you can see, I've actually attached a depth camera, which showcases one of the very powerful features of Gazebo. This is just a sample world, and I'll show you how to download this and get this on your device and your simulation. But this is just one really cool example of what you can do. And also because it's in a Gazebo world, you can add obstacles. I will be doing this later, and I'll show you how to do that. Finally, here's ROS and MAVROS. MAVROS has a bunch of different topics and services that allow you as the programmer to call and thus control the drone. This is where everything comes together. As you can see up on the right, it says PX4 Autopilot, and there's a flight controller to the left of that. On the complete other side, you can see there's an onboard computer right next to the right of the ROS. And the bottom middle, you can see all the different topics and services you have. The ones shown here are mostly related to data you might want to have, such as the position of the drone. There's significantly more topics and services you may find useful, and you can find all of these on the MAVROS wiki page. Now that we've seen what each of these components are, let's go ahead and move and see a demonstration of all of these components. Let's show a demonstration. Right now I'm launching both the Autopilot SITL as well as Gazebo and Arvis to showcase the depth camera. Let's wait for this to load up. Okay, here's our drone. And we're out here in this field, this airfield here. And then let's go back. So here's the map of the SITL, though this may not necessarily reflect your Gazebo world. In fact, you probably have to change the starting location here if you're trying to do some sort of Gazebo replication of some sort of part of the real world. But that's pretty simple to do, and I can show that at a later video. So we want to make this drone fly. And there's a way just using the software in the loop here. We can go into that mission editor, and then we can read waypoints. I already had all these waypoints preloaded, and I can show you exactly how you would program using MAVROS to get waypoints like these at a later time. So now that we have read all the waypoints and they're all set, it's time to take off. So remember, this terminal fundamentally simulates commands going to the flight controller. And these same commands can also be done in ROS, but just for the purposes of showing the SITL, I am choosing to do it this way by typing the commands in manually. We can first change the mode to guided. This will make our lives easier when we're trying to do autonomous takeoff. By the way, here's the RViz showing the depth camera. But we don't need that for now. Now, we can go ahead and arm the drone like you would in real life. As you can see, the propeller starts spinning. Now we can give it a takeoff command, and it'll take off just like that. And then now we're going to switch to the autonomous mode, and now it'll start following the given map over here. So as you can see, it's going to go toward that second waypoint there, where there's like that straight purple line between the drone and there. As you can see, it's flying right over here. And here is a video of that. And let me pull up the map. So as you can see, it's currently heading in that direction over there. And then once it gets there, you should see that it makes a slight turn. It's got there and made that turn, and now it's going to continue along its path here. And that's the basics of the drone simulation. Now, if you wanted to run ROS code, in addition to this, you can effectively start up your own node here. It could be in the same launch file as the launch file for the Gazebo, but I've kept it separate so that when you deploy it in the production environment, there's only like a few packages you need to download as opposed to like Gazebo and everything else. So thank you everybody for watching this video, and I hope to keep you posted about all the new installation processes. Thank you.